Hello everyone. Today we are interested in getting the equation for the rectification efficiency or it is also called as the rectifier efficiency for the half wave rectifier. Before we proceed, let me just recall that some of the equations that we have already derived or some equation that we all should know already before going for this derivation. First equation is of IDC, that is Im by pi. Then what is the equation for Im? It is Vm by Rs plus Rf plus Rl. These are all equations we have derived. Now Irms, that is the RMS value of the current which is flowing for half wave rectifier, is given by Im by 2. And for full wave rectifier, the RMS current is given by Im by root 2. These are some equations that we all should know. If you are not knowing, kindly go through the derivations in the lectures in which we have already taken them. Okay, now let us go for our topic, that rectification efficiency of half wave rectifier. Normally we know that the efficiency is associated with the input and output, and efficiency is always defined as output divided by input. So in rectifier also it is given by the same equation, output by input. In case of the rectifier, output is a DC and input is a AC, and that's why the equation for the efficiency becomes the ratio of DC output power to the AC input power. As we are giving AC as an input and DC is output, so output by input is nothing but our efficiency. It is also given by PDC by PAC, right? So it means that in order to calculate the value of efficiency, we should get the equations of PDC and PAC, where PDC represent the DC output power and PAC represent the AC input power. So firstly, let us go for the PDC, that is nothing but the output power available in case of the rectifier. So we know that power is nothing but the voltage into current. So that's why let us write this equation, that power is multiplication of DC voltage to the DC current. Further, we know that this EDC can be written like IDC into RL, right? And this IDC as it is. So in that way, we are getting the equation for equation of PDC is equal to IDC square multiplied by RL, right? Now we have already taken this equation here. IDC is given by Im by pi. So putting this equation here, what we are getting, the equation for PDC is equal to Im by pi bracket square, and this is multiplied by resistance RL. So that is the equation for the DC power which is available at the output of the half wave rectifier. Now in the same manner, we are interested in getting the equation for this, which is the PAC, means the AC power which is applied as a input. Now we know that in the one of the circuit also we have seen that the power is applied to the load resistance. Here this is indicating the values. It is applied to the resistance, load resistance. Also there is some resistance in the winding, and this is the diode forward resistance. This thing we have already discussed in the previous lectures. So in that way, the equation for AC power which is at the input side is given by, as it is AC, so we should be taking the RMS value. So it is I RMS square multiplied by the value of resistances. So all the resistances we should take RS plus RF plus RL. Actually this is the nothing but the equation of power is equal to I square into R. So I, here we are talking about AC, that's why we have taken the RMS value and all the resistors that are coming in the circuit. So now again we have seen that in case of the half wave rectifier, the value of IRMS given by Im by 2. Here remember one thing, it is Im by 2 in case of half wave. In case of full wave, it is Im by root 2. Derivation for the same thing is also available. Okay. Now putting this value here, we are getting this equation for the PAC is equal to Im square divided by 4, because this 2, it's a square, become 4, and this resistances as they are. So Rs plus Rf plus RL. So now we have got the equations for the DC power which is available at the output of rectifier, and AC power which is given as a input to the rectifier. Now we can calculate the, or we can get the equation for the this efficiency simply by putting the PDC and PAC here. So the equation for the efficiency in case of half wave rectifier is, so PDC, this value will be putting here. So it is Im square by pi square multiplied by RL. Then this thing will be divided by PAC. So this equation we will be putting here. So it is Im square by 4 in bracket Rs plus Rf plus RL. So further it is very simple. Now this Im square and Im square will get cancel, and solving further, what we are remaining with is, we are only remaining with 4 by pi square into RL divided by Rs plus Rf plus RL. I hope you can understand that directly I have solved. This Im and Im get cancelled. This 4 will come on the upper side. After solving, you will get the same equation, that is 4 by pi square into RL divided by Rs plus Rf plus RL. Now this can be the final equation for the efficiency of the half wave rectifier. Solving this further, 4 divided by pi square will get one value, and that value comes to be 0.406. So in that way, the equation for efficiency now becomes 0.406 multiplied by RL and divided by this Rs plus Rf plus RL. Right? In the last lecture also we have shown that, or we discussed this thing, that value of this Rs, which is the secondary resistance, and value of this Rf, which is the diode forward resistance, these two resistances are having very small value. So that's why we have Rs plus Rf. It is very small as compared to the value of the resistance RL. So in comparison with this RL, these two values are very small, and that's why we can neglect them. So if we neglect them, what remains? In numerator we are having RL, in denominator also, after neglecting this, we are remaining with the RL only. So that's why this RL will get cancelled, and finally we will have this thing only. So that's why it is said that the efficiency of the rectifier, half wave rectifier, can be 40.6. Now I am writing in percentage, that's why it is 40.6. So that is the maximum possible efficiency we have. That's why it is also said that the maximum possible efficiency in case of the half wave rectifier is only 40.6%. Okay.